ओके, NCERT एग्जाम्पलर डायरेक्टली यहाँ से भी सवाल आ जाते हैं आपके पास नीट में. सो योर duty is to complete NCERT exemplar. Start with match the following in NCERT exemplar. Okay, then do MCQs and assertion and reason questions. Okay, start with match the following. Match the following is still correct because match the following has very easy questions, so that you will just get started, and it also give you an overall idea about the chapter. क्योंकि अगर आप chapter complete करके आ रहे हैं, then you should have overall idea कि कितना क्या है, कहाँ पे नहीं है. So match the following, then MCQs, and then assertion and reason. ठीक है, चलिए try this question first of all. For a chemical reaction 4A plus 3B gives you 6C and 9D. The rate of formation of C is this much. Rate of disappearance of A is this much. The rate of reaction and amount of B consumed in interval of 10 seconds. So you have to calculate the rate of reaction. Okay, so I'm just giving you some hint. Rate of reaction for any chemical reaction will be equal to 1 upon the stoichiometric coefficient minus the rate of appearance of, or rather rate of disappearance of A. Rate of disappearance of A is delta A upon delta T, right? Will be equal to 1 by 3 minus delta B upon delta T. Okay, this quantity here with the negative sign, it is what it tells you about the rate of disappearance of A. Okay, similarly, I will have 1 upon 6 delta C upon delta T will be equal to 1 upon 9 delta D upon delta T. Okay, so these terms with the negative sign, but without the stoichiometric coefficient, these things tell me about this is the rate of disappearance, this is the rate of appearance. To try this question, I will give you guys 2 minutes. And send your answer on Zoom chat and send it to Salim. Don't send it to Learnivio, otherwise I will not get your answers. Okay, send it to Salim. Yeah, okay, Ram, I think that is correct, but we will see. Seems like it should be correct. Okay, if you guys are stuck, please see. Arpit, are you stuck?
Sir, I'm doing it.
You're doing it. Okay. How much more time will you need? 1 more minute?
Sir, I got the rate of reaction of B, but what is the amount consumed, sir? That is confusing.
Okay, fine. Not a problem. ठीक. First of all, I hope all of you saw the equations. Okay. What they have told? They have told rate of formation of C is 6 into 10 to the power minus 2. That means I will write the rate of reaction in terms of C. This will be equal to C is the product, so it will be positive 1 by 6 into rate of formation of C, right? Rate of formation of C. So the rate of reaction will be equal to 1 upon 6 into 10 to the power minus 2. So the rate of reaction becomes 10 to the power minus 2. Okay, correct? Yes or no, please tell me. So option
Yes,
A is
sir.
right. No, option A cannot be right. Option C, it cannot be right. The only option that is remaining is 1 and D. Now what they're asking, and the rate of appearance of this much is this much, the rate of reaction and the amount of B consumed in the interval. Amount of B consumed, please see. I will write rate of reaction will be equal to 1 by 3 into amount of B consumed, delta B, the change in concentration of B, divided by the change in time. What is the change in time given? Change in time is given as
10.
10. Okay. Amount of B consumed will be equal to ROR, whatever the rate of reaction you got, into 30, right? So 30 into 10 to the power minus 2, B will be the correct answer. Rate of reaction 10 to the power minus 2 मिला था हम लोगों को, right? So 10 to the power minus 2 into 30. Just give me a minute, guys. Is it clear, everyone? Yes or no? Please tell me.
Yes,
Kiram,
sir.
Heather, Anna, clear?
Yes, sir.
Okay, fine. चलो, very similar question. ठीक है? Write the correct answer. And this thing ROR is equal to 1 upon stoichiometric coefficient minus the change in concentration of the reactant divided by change in time. This should be going up in your head. You don't even have to write this down. So this question again, it should be done without picking up the pen. Right now you can pick up the pen. In the examination हम बात कर रहे हैं, okay? Okay, I've got two answers. Answers are different. Once again, एक बार let me see. N2 N अच्छा NST सबके बारे में दिया. A तो नहीं हो सकता, B C भी नहीं हो सकता. हैदर फिर से देखिए एक बार आप. See, there will be a minus sign on reactants as they are consumed. सही है? And positive sign कहाँ पे होगा? On products as they are formed. So this negative sign is telling me that the reactant is being consumed would decrease over amount. That is why we have the negative sign. And positive sign tells me that the product is being formed. So in this case, I think the D option is not right either. -1/2 नहीं होगा ना NH3 के लिए, it will be 1/2. So
Yes,
B
sir.
option is correct. Okay. Heather आपने क्या दिया था? Heather got B. Okay. What about others? Anna and Iram. Yes, Anna, tell me. कहाँ confusion हो गया आपको?
Ma'am, sir, I got it. I got the answer. I
Got it.
just
Okay.
did
What
not
about
get
you,
it.
Iram? Yes, Iram. I can't hear you. I can't hear you, Iram. Sorry. As we have already seen, for a chemical reaction in which we have A plus B giving C and D, where N1, N2, N3, and N4 are stoichiometric coefficient, the instantaneous or the average rate of reaction will be rate of reaction is equal to -1 upon the stoichiometric coefficient of the change in concentration of A divided by change in time. Okay, including this minus sign, including this minus sign, okay? Except the stoichiometric ratio, this is the rate of disappearance. ठीक है, इसको ध्यान रखिएगा. What is rate of disappearance? Please see. Rate of disappearance is equal to of A is equal to minus dA by dt. It does not have to do anything with the stoichiometric coefficient. Now, how will you remember this? Please see. When you are thinking about rate of disappearance of A, you are looking at a chemical reaction and you are seeing the A disappear. Now, it doesn't matter what the reaction is happening. You are just looking at A. So when you are just looking at A, stoichiometric coefficient का वहाँ पे कोई लेना देना नहीं. Stoichiometric coefficient is of no use because stoichiometric coefficient is of use in reaction. So when you are calculating rate of reaction, then you will think of stoichiometric coefficient. But when you are thinking about individual reactant molecules or individual product molecules, then you will not think about stoichiometric coefficient because stoichiometric coefficient is specific for a particular reaction. Okay, so rate of disappearance and rate of appearance, both of them do not have any role with the stoichiometric coefficient. Now, the unit of rate of reaction will be always moles per liter per time. Moles per liter per time. Now, in the case when you have gases, in that case, you will have ATM time inverse. Okay. So we will have pressure and time inverse. When you have liquid, you will have concentration, that is moles per liter per time. But when you have pressure, it will be ATM time inverse. Okay. Now, rate of reaction will always be positive. Rate of reaction will always be positive. It will never be negative. कभी negative आए तो फिर से देखिए कैलकुलेटर में कहीं पे mistake हो रही होगी. Now, then we have the rate law. This is experimentally determined rate expression, and it says that rate is equal to rate constant multiplied by the concentration of reactants to some stoichiometry to some power. Now, this power x and y, these are known as x. Since it is a to the power of x, it will be order of reaction with respect to A and order of reaction with respect to B. The sum of x and y is known as the order of reaction, the overall order of reaction. Okay. Now, order is an experimentally determined quantity. You cannot look at the stoichiometric coefficient and वो कभी भी आपको कभी भी नहीं हो सकता है और हो नहीं भी सकता है. Okay. So order is an experimental quantity. It may be 0, it may be positive, or it may be fractional. ठीक है. A के रेस्पेक्ट में B के रेस्पेक्ट में पॉजिटिव भी हो सकता है, नेगेटिव भी हो सकता है, फ्रैक्शनल भी हो सकता है. The unit of K will be equal to mole. देखिए इसको डिवाइड कर सकते हैं आप लोग. I hope all of you know this. The rate of reaction is equal to K into concentration of A to the power of N, where N is the order of reaction. So I can write K is equal to rate of reaction divided by A to the power of N. Now, what is the unit of rate of reaction? It is always moles per liter. Let us suppose second inverse divided by the concentration ka. What is the unit of concentration? It is moles per liter to the power N. Now, moles per liter second inverse divided by mole to the power of N. ये हो जाएगा mole to the power of N. Liter inverse to the power of N. ये हो जाएगा liter to the power of minus N. Okay. Now, when the mole will go above, it will become mole 1 minus n. Liter में हमने -2 कर दिया, minus n होगा, sorry. So it will be minus n. Okay, now liter will become what? N ऊपर जाएगा तो positive हो जाएगा. It will become n minus 1 and then second inverse. And then second inverse. So in total, you can see it like this: mole to the power 1 minus n is and to liter to the power n minus 1 into second inverse. Or you can just remember mole per liter, moles per liter 1 minus n. It can also be written as moles liter inverse to the power 1 minus n into time inverse. Okay. Now, similarly, if you have gases, then ATM to the power 1 minus n time inverse. Now, K only depends upon temperature, catalyst, and nature of reactant. If you change the temperature, K will change. If you add a catalyst, then the catalyst is going to be another reactant. It is not getting consumed, but it is taking part in the reaction, and that is why it will change the course of reaction. That is why change the K of the reaction. Similarly, if you change the reactant, obviously the rate of reaction will change. Now, moving on. I hope all of you have seen how to calculate or how to determine the order of reaction and the rate law expression using experimental values, right? So we do multiple experiment in which we take different values for the reactant molecules. Okay, we take different values for the reactant molecules, and from that we can determine the rate law expression. Okay, now all of you must have done this type of question for the board examination. Next, we have the zero order reaction. Important thing is to also remember that what are the different types of zero order reaction. All the decomposition of gases, photochemical reaction, and enzyme catalyst reaction. All of these are what? Zero order reaction. All of these are zero order reaction. The decomposition of gases depends on the area or the surface area of the metal. If you have more surface area, the reaction will be faster. It will not depend on the reactants. Photochemical reaction, it depends on the H nu. What frequency of light you are hitting, that determines the rate of reaction. In enzyme catalyst reaction, enzymes determine the rate of reaction. If they are good enzyme, then those reactions are going to be faster. Now, in zero order reaction, R is equal to K into A to the power of 0. Now, this equation, you have to remember the integrated form of the rate equation. You can also remember it like this: KT is equal to initial concentration minus the concentration that you are having at a particular time. T half, also remember please, T half of this reaction is equal to A naught upon 2K. T half of a zero order reaction is directly proportional to the initial concentration. If the initial concentration is high, the T half will also be high. What is T half? The time taken for 50% consumption of the reactant. Time taken for 50% completion. Time taken for 50% consumption. 100 से 50 जाने में जितना time लग रहा है, that is known as the T half. It is known as the T half. Actually, please write this graphs also. First graph is between, let me zoom in. First graph is between the concentration, that is A, and time. Concentration and time. So obviously, concentration of the reactant is going to decrease as the time increases. Then we have X. X is the amount that has reacted. Amount that has reacted. So amount that has reacted will increase with respect to time. More and more reactant is being consumed. It has reacted with respect to time. Now, concentration versus rate, as we have already seen, that the rate does not depend on the concentration because it is a zero order reaction. So no matter if you increase the concentration, the rate is going to be constant. Rate is not going to change from this value. Next, we have T half and AT. Both of these are directly proportional. So it is passing from the origin and it is increasing as we, T half is also increasing as we increase the initial concentration. So please write these things down for zero order reaction. All the graphs are important.
Can you explain the integrated rate equation again and differential rate equation?
Again. You want me to derive it? Yes.
So just like overview kind of.
See, अच्छा मतलब what are the plugins you have to see? Minus dA upon dt तो आप लोगों ने देखा है ना पहले ही.
Yes.
Right. ठीक है. Now K into A to the power 0. ठीक है. Integrated rate law equation is KT is equal to, or rather we can say concentration of A at a particular time will be equal to the initial concentration. A0 is what? Concentration of A at time is equal to 0 minus the rate constant into time. Minus the rate constant into time. For zero order reaction, देखिए किस चीज पे डिपेंड करेगा? The rate of reaction is going to depend on the K as well as the time. कितना react किया है? What amount has reacted? It will depend on what? It will directly depend on the rate constant. If the rate constant is high, more amount will be reacted. And as the time increases, more amount will be reacted. That is why initial concentration से कितना घट जाएगा? K into T. Okay. K is the rate constant, T is the time.
Okay. And so in the last graph, what is on the x-axis?
X-axis में आपके पास है A0, initial concentration.
Okay.
Done all of you, Sonopi Sami? Is everyone done? No, yes. Can you please answer?
No,
Yes,
sir,
and now
just a minute.
Haider. Just a minute. Okay.
So the value of K will be given in all the questions, right?
नहीं, ऐसा नहीं जरूरी के हर में दिया रहेगा. आपको के निकालना भी तो पड़ सकता है, बाकी की दिए रहेंगी,
अच्छा.
है ना? टाइम दिया है, नॉट दिया है. हाउ मेनी वेरिएबल्स डू वी हैव हियर? 1 2 3 एंड 4. 4 वेरिएबल है. 4 में से आप क्या दे देंगे? वो 3 दे देंगे, एक निकालने के लिए कहेंगे. अंडरस्टूड?
Yes, sir.
Now there are different ways of giving those information. है ना? ऐसा लगेगा आपको चारों की सारी इंफॉर्मेशन नहीं दी हुई है, but it would be given. You will look at the question and then you will understand. चलिए, I hope everyone is done by now. Next important order of reaction that you have to learn is the first order reaction. First order reaction, if there is a mention of all radioactive decay, any radioactive decay, then you will understand it is a first order reaction. And if it is mentioned that it is a pseudo first order reaction, then also the following equations are valid. In this case, the rate of reaction will be equal to the rate constant multiplied by the concentration of A to the power of 1. And when you integrate on both the side, and first of all, you have to do it like this, dA upon dt. And then you do variable separation. And after that, when you integrate it, you will get the formula KT is equal to 2.303 log of A0 upon AT. KT is equal to 2.303 log of A0 upon AT. Please write this down. Now, all the graphs will be in terms of log in this case. So when you have log of the concentration, it is going to decrease with respect to time, because as the time increases, the amount of reactant is going to decrease. The slope of this graph will be according to y is equal to mx plus c, or rather y is equal to mx plus c, it will become minus k upon 2.303. Minus k upon 2.303. Okay. Now concentration with respect to rate, as the concentration increases, the rate is also going to increase. That is why the concentration increases and the rate increases. Important thing here is the T half. T half of first order reaction is not dependent on the initial concentration, and T half is equal to 0.693 divided by K. One more important thing is that T of 75% or T 3 by 4. This is T 50%. Then you have T 3 by 4. This will be equal to 2 times of T half, or 2 into 0.693 divided by K. This is T 75%. Why is this happening? Please see here. When you go, please don't write anything right now. Please to me. When you go from 0 to 50%, let us suppose you are taking 50 seconds. ठीक है? 0 to 50% आपको क्या मिला? 60 seconds. 50 seconds means 0 to 50%. Now, when you are in the 50%, the reaction does not care what is the amount of reactant. The reaction does not care what is the amount of reactant in order to determine T half, because T half is independent of the reactant's concentration. So once again, आप 50 से 100 के बीच कहाँ पे होगा? 75% पे होगा, right? 50 to 100, what is the middle point? 75%. Now from 50 to 75%, you will again need what? 50 seconds. Now from 75 to what is the middle? 87.5, na? 75 से 100 का बीच middle part कहाँ पे आएगा? 87.5. This will again take 50 seconds. Okay. So also write one more thing. T of 87.5% will be equal to 3 times 0.693 divided by K, or you can also write this as 3 times into the T half. And in general, this equation is important. The above ones are not very important. उससे सवाल कभी आता नहीं है. It's very high level. T half is equal to, or rather T half is proportional to 1 upon A naught to the power n minus 1. This is important. इससे सवाल आ सकते हैं. This is for general nth order reaction. If the order of reaction is n, let us suppose.
AT in the integrated rate equation is the final concentration.
This is the final concentration, or the concentration at time t. Sorry. Understood, Heather?
Yes, sir.
So you can explain the graph of the first order reaction.
This graph, this
Yes,
one.
sir. Yeah, the first one.
So here we have log of A. Okay. So log of the concentration of the reactant. What will happen as the time increases? Reactant की concentration क्या हो जाएगी? Decrease करेगी, increase करेगी?
Decrease करेगी.
So that is decreasing, right? If
Yes.
you want to know what is the equation जहाँ से ये आया है, so I hope you can write this as 2.303 कहाँ लिखे हो? You can write this equation as KT is equal to, or rather I will write it like this. KT upon 2.303 is equal to log of A naught minus log of A using the rule of law. A upon B is equal to log A minus log B, है ना? अब इससे हम
Yes.
क्या लिख सकते हैं? Y is equal to mx plus c के हिसाब से, right? So minus log A को हम इधर ले आते हैं. So it will be plus log A, right? This will be equal to log A naught minus KT, this KT upon 2.303. It will go on the right hand side. It will become minus KT upon 2.303 minus KT upon 2.303. So this T term is my X. This whole term minus K upon 2.303 is my M, that is the slope. Log A naught is my C, that is the intercept. And this log A is my Y. So Y is equal to MX plus C. So you have a slope intercept form of line which is passing from this C. This is log A naught. Clear, Harpit?
Yes.
Okay. All of you done? Yes or no? Please tell me. Can we move towards questions?
Done, sir.
Done. Should we try this one? When the initial concentration of reactant is doubled, half-life period of a zero-order reaction will be what? So it goes towards that formula.
Halved.
T half is equal to, T half is directly proportional to A naught, na? ध्यान से बताइए क्या होगा आंसर? For a zero order reaction, what is T half? T half is, even if you look at this equation here, if you write 0 here, T half will be directly proportional to A naught. So write the answer in chat. What will be the answer in chat? Yes,
T
Arpit,
half
correct.
is inversely proportional or directly proportional?
For a zero order reaction, or for an n order reaction. देखिए n order reaction
Zero
के लिए
order.
आपके zero order के लिए तो directly proportional है ना? You
Yes,
remember,
sir.
either you can remember this formula. T half is 1 upon A naught to the power n minus 1. अब n minus 1 में आप 0 रखिए. So it will become what? Minus 1. So A naught denominator will go in the numerator. A naught into the power of this. A naught to the power minus 1. Or is T half directly proportional to A naught. So zero order reaction के लिए directly proportional. I hope you have seen here.
Yes, sir. Yes, sir.
ठीक है. So the answer will be, if the reactant concentration is doubled, the half-life will also be doubled. If the rate constant of first order reaction is K, the time T required for the completion of 99% of the reaction is given by. No, this is first order reaction. And in first order reaction, it is equal to KT is equal to 2.303 log of A naught upon A. Log of A naught upon A. Okay. Now, they have given K, they have asked the time, right? They're asking what is A naught and what is A. That information is given here. For the completion of 99% of the reaction. 99% complete हुआ इसका मतलब A naught is equals 100 और 100 में से 99 react कर चुका है. That means A will be equal to what? A will be equal to 1. So you plug in those things. ठीक है. Also what I'm doing, हम K को यहाँ से हटा के KT था. So I'm removing that K and I'm writing T here and this is divided by K. Okay. Log of A naught is equal to what? 100. And remaining concentration is what? Because 99% has been completed. Remaining percentage will be 1. So log of 100 will be equal to what? 2. Yes or no, please tell me. Log 100 with base 10 will be equal to 2. Why? Because 10 to the power of 2 will be equal to 100. This is the basic theme of log. So this will be equal to 2 into 2.303 divided by K. What is the correct option? Choose the correct option.
A. Sir, can you please explain this log function again?
Should I explain this part or the calculation part?
Sir, this log part that you just erased.
Oh, अच्छा.
Calculation part, yes.
Calculation part ना, ठीक है. देखिए हम it will take a bit of time, लेकिन ये सबके लिए clear कर देगा. ठीक है. In mathematics, when you have 2 plus 3, it is equal to 5. ठीक है, ध्यान से सुनिएगा. अजीब लगेगा फिर भी ध्यान से सुन लीजिए. 2 plus 3 is equal to 5. Now I am writing 5 in terms of 3 and I am writing in terms of 3 and 2. Similarly, I can write 3 in terms of 5 and 2. कैसे लिख सकते हैं हम? 3 is equal to 5 minus 2. Similarly, I can write 2 in terms of 5 and 3 also. How can I write that? I will write 2 is equal to 5 minus 3. So if you have 3 terms here, then you should be able to write 3 different equations. ठीक है? This is the basic. This is some maths that आप लोगों को नहीं पढ़ाया जाता है. ठीक है? This is some maths that आप लोगों को नहीं पढ़ाया जाता है. Rules of math की rules, maths में क्या-क्या rules होने चाहिए जहां से आपके पास basic algebraic operations निकल के आते हैं. Next we have, let us suppose 10 to the power of 2. ठीक है? 10 to the power of 2 is equal to what? It is equal to 100. Now here also what we have here, we have 3 terms. We have 10, we have 2, and we have 100. So I can write 100 is equal to 20 by 2. और दूसरी चीज हम क्या लिख सकते हैं? I can also write 10 is equal to क्या लिख सकते हैं हम लोग? 100 to the power 1 by 2. ठीक है, 100 to the power of 1 by 2. Now here also I am writing in terms of 10. How can I write 2 is equal to using 10 and 100? तो उसके लिए निकला log. ठीक है, just to satisfy, there are 3 terms, so there should be 3 different equations. 2 is equal to what? Log of 100 with base 10. ठीक है, इसका क्या मतलब होता है? 10 to the power 2 will be equal to 100. 10 to the power 2 will be equal to 100. This is the basic starting place of log. जहां पे जो भी बेस होता है इसका, when you write log, it is base 10. ठीक है, so 10 to the power 2 is equal to 100. Similarly, if I write log of 10 to the power 3, that means 1000. So this will be equal to what? 10 to the power of 3 is equal to 1000. Okay. Another way, शायद आप लोग को ये याद हो कि log 100 को हम लोग इस तरह से लिख सकते हैं, log 10 to the power of 2, then 2 will come down, है ना? ये बन जाएगा 2 into log 10, and log 10 की वैल्यू होती है 1 किलो. log 10 की वैल्यू 1 क्यों होती है? Because log 10 base 10, 10 to the power 1 is equal to 10. ठीक है, understood? हैदर,
Yes, sir.
समझ में आ गया log?
Yes, sir. आगे
ओके, यही पूछ रहे थे आप या कुछ और पूछ रहे थे?
यही पूछ रहा था sir.
ठीक, चलिए, this is a good question. Please see this. Okay, Arpit has given me an answer. I will give you one more minute, guys. ठीक है, redetermining step कौन सा होता है? You have to answer it from that perspective. ठीक है, take one more minute and then I will explain it. Arpit, आपका तुक्का है या फिर you have some explanation?
Yes, sir. Like I give a thought.
So you have a thought, no? You have explanation. Okay. Yes, Arpit, can you explain? How did you get the answer as B?
Sir, I guess it's not correct because sir, I just thought that the coefficient or the power is not correct. So I gave a thought that it should be 0.
No, that is not the case. all of you know that there are two types of reaction: elementary reaction and complex reaction. Elementary reaction, it happens in one step, single step. Complex reaction happens in multiple steps, right? So elementary reaction, for an elementary reaction, the rate of reaction is equal to the stoichiometric coefficient. Whatever the molecularity is there, those are the stoichiometric coefficient will give you the order of reaction. But for a complex reaction, we cannot say that. So in a complex reaction, what is the rate determining step? Which step is the rate determining? Slowest step or fastest step? Which step is the
Slowest
rate
step.
slowest step, right? So from in this mechanism, I can say that my rate determining step is the second step is my rate determining step. Acha, one thing, all of you are clear about this, na? The slowest step is the rate determining step. Anna, Arpit, and Iram.
Yes, sir.
Yes, Arpit, you are also clear about this?
Yes, sir.
Okay, fine. So now I can write the rate law expression as rate is equal to K into the concentration of X into the concentration of Y2. But the problem with this rate expression is that X is not my reactant. क्या X reactant है? देखिए. X is not a reactant, na? Yes or no? Can all of you see that X is not a reactant? X2 is a reactant. Correct? Oh, can I get a yes or no, sir? Anything, please?
Sorry, sir, what did you ask? Can you repeat it?
Achha, am I not audible?
No, sir, my
Am I-
internet connection is a bit slow today.
Okay, what about others? Please answer, guys, okay? If this is my slowest step, this is my rate determining step. And all these steps in a complex reaction is elementary reaction. All of these reactions are elementary, right? These are steps, so ये तो single step नहीं होगा. So that is why I can write the rate is equal to K into the concentration of X multiplied by the concentration of Y2. Multiplied by the concentration of Y2, because this is the rate determining step. Is this clear? Yes or no? Please tell me, Anna, Arpit, and Aram.
Yes, sir.
Clear,
Yes,
sir.
ठीक है.
Yes.
But is X a reactant? बताइए. This is my main reaction, na? X2 plus Y2 give you XY. Is X a reactant? Yes or no? Tell me.
No.
No, X is not a reactant. So I have to write the rate law expression in terms of X2 and Y2 only. Now, how can I write X? You can write K for the fast reaction. Equilibrium constant for the fast reaction will be equal to, the product is what? Concentration of X square, because we have 2X here, divided by the reactant, that is X2. Okay? That means I can write this as K into concentration of X2 okay? This will be equal to X square. Now I can write X is equal to K into the concentration of X2 root. Correct? Any difficulty in calculation? हाँ जी बताइए. Yes or no? Please tell me, guys. Any difficulty in calculation?
No, sir.
What
No,
about
sir.
Anna, Arpit, Aram? Please, yes or no? कुछ तो बोलिए. आप लोग लिखने मत लगिए, please. This is the equilibrium constant will be equal to the concentration of the product raised to the power of stoichiometric coefficient divided by the reactant's concentration of the reactant. Okay, so I can write X is this term. R is equal to K into concentration of X is equal to what? Root of K into Y2. Now I can write this as K into the root of K and concentration of X2 to the power of half into the concentration of Y2. Now this is a constant, this is also a constant, this will become another constant K dash, concentration of X to the power of half, concentration of X2 to the power of half and concentration of Y2. So my rate of reaction will become what? Half plus 1, that is equal to 1.5. So the correct answer will be C.
Well, can you explain this again from the first step in that white ink?
Achha. See, this X है ना, is equal to root under K into X2. ठीक है?
Yes, sir.
उसी को हमने replace कर दिया है. Okay. Now k to the k का भी रूट है और x2 का भी रूट है. So if you have 4 into 8 root, तो आप क्या लिख सकते हैं? Root of 4 into root of 8 लिख सकते हैं. That is
Yes,
why I
sir.
have written root of k, and root का मतलब क्या होता है? Half होता है ना, power of half, right? Yes or no?
Yes, sir. Yes,
I
sir.
have written k into x2 to the power of half into y2. Now k is also a constant and this is also a constant, है ना? एक equilibrium constant और एक rate constant. So both of these constant will give you another constant multiplied by x2 to the power of half and into y2. So the order with respect to x2 is equal to 0.5 and order with respect to y2 is equal to 1. So when you add them, you will get 1.5. Understood, Heather?
Yes, sir.
Okay. Please write this down.
Why didn't we consider the k dash in the final step?
So why did we?
Why didn't we consider the k dash in the final step? Like, what will we do about that constant now?
What are they asking, Heather?
Order of the reaction.
Order of reaction has only to deal with, even if you don't write anything here, the order of reaction will just deal with the concentration terms, no?
Yes, sir.
Not the constants, right? So this is one type of question that can be asked, so हमने इसको करा दिया है. ठीक है? So if you get a mechanism type of question, बहुत सारे लोग जो पढ़ते हैं वो directly क्या लिख देते हैं? Molecularity of x is 1, molecularity of y2 is also equal to 1. So इस particular reaction के लिए order है 2, that is why the rate determining step order 2 है, तो यहाँ पे भी order 2 होगा, that is why 2 option आपका first ही है ना? तो please don't do it that way. आप जरूर देखिएगा, whatever rate law you are writing, are they having the concentration of reactant of the reaction or not? है ना? तो x2 और y2 रहना चाहिए यहाँ पे, not any intermediates.
Done, sir.
Write this next question. Yes, any answers, guys? The direct question from the graphs. Yes, very good, Heather, correct. From the graph, I can say y is not dependent on x. This is the statement that you are getting from the graph. Y is not dependent on x. Okay. Now, first option, zero order के लिए concentration not dependent on time. Concentration not dependent on time. ऐसा तो कुछ होता नहीं है ना? Then we have t half not dependent on concentration for the first order. ये सही है, ये गलत है. So this is not the correct option. Zero order concentration time, ये तो गलत ही हो गया. C option देखिए, rate is not dependent on concentration for a zero order reaction. Rate is not dependent on concentration for a zero order reaction. That is true because R is equal to K into A to the power of 0. A to the power of 0 का क्या मतलब हुआ? R is equal to just the rate constant. So rate is not dependent on the concentration. Now, then you have T half is independent of concentration for a first order reaction. For a first order reaction, that is also true. Because for a first order reaction, T half is equal to 0.693 divided by K. 0.693 divided by K. Again, you don't have any concentration term. So C is the right option. Please write this down and then look at the next question. For a first order reaction, A giving products, initial concentration of A is 0.1, which becomes 0.001 after 5 minutes. The rate constant for the reaction in minute inverse is equal to how much? This is an easy question. तीन चीज दिया हुआ है आपको, initial, final and time. They're asking you the rate constant for a first order reaction. So write the correct equation, है ना, गलत equation मत लिखिएगा. Arpit, did you calculate?
Yes, sir, I
Arpit,
did.
tell
Sir,
me what is the
should I
formula
send the
that-
photograph?
Where did you send the photograph?
I am saying that can I send? I have done the calculations.
No. I'm asking what formula are you using?
Sir, I use K equals to 2.303 T by T log initial concentration by final.
Initial concentration is 0.1.
Yeah.
0.1 को क्या लिख सकते हैं? 10 to the power of minus 1 लिख
So
दें?
10 is to minus 1 upon 10 is to minus 3.
Minus 3. So this would be equal to 2.303 divided by 5 into time 5 minutes है ना?
Yes, sir.
Into क्या हो जाएगा? 3 minus 1 2 into 2, right? Correct है? This is how you did, Arpit, या कुछ और तरीका आपने यूज किया? Those who don't get 2, please see 10 to the power minus 1 and 10 to the minus 3. So it will become 3 minus 1. This is equal to 10 to the power 2. Log of 100 is equal to 2, as you have seen earlier also. What will be the answer? 4.606 डिवाइड बाई 5, तो अप्रोक्सीमेटली 0.9 के करीब आएगा। बी इज द करेक्ट आंसर।
मेरा 2.9 समथिंग,
सॉरी, जोर से बोलिए, जोर से।
तो मेरा 2.9 समथिंग आ रहा है।
2.9 आ रहा है। 4.606 डिवाइड बाई 5। हैदर,
यस सर। सर मैंने थोड़ा सा अलग तरीके से किया है।
नहीं, ये लास्ट इक्वेशन ये आ रहा है या कुछ और आ रहा
नहीं
है?
सर, ये नहीं है लास्ट इक्वेशन।
ये नहीं, ठीक है। आप फर्स्ट इक्वेशन ये है, ये भी नहीं है,
यस सर, ये तो है।
ये है 10 to the power -1 upon 10 to the power -3 है।
सर मैंने इसको 0.1 और उसको मतलब
हाँ, वो
डेसिमल
भी
उसको
ठीक है।
फ्रैक्शन में कन्वर्ट किया।
0.1 अपॉन 0.001 है ना।
यस सर।
सो 0.1 को हम कितने से मल्टीप्लाई करेंगे तो 0.1 आ जाएगा। इसको हम कितने से मल्टीप्लाई करेंगे तो आएगा 100 से, राइट।
यस सर।
सो दिस विल बी इक्वल टू व्हाट, इट विल बी इक्वल टू 100 ओनली, है ना।
हम्म।
ठीक है, तो आपका लॉग क्या आ गया, लॉग 100 आ गया।
यस सर।
लॉग 100 इज इक्वल टू 2।
ओके सर, सर ये स्टेप गलत हो गया था।
ये बहुत सवाल है अभी। राइट दिस क्वेश्चन अगेन सेम। फर्स्ट ऑर्डर रिएक्शन हैज अ स्पेसिफिक रेट ऑफ रिएक्शन, इसमें के दिया हुआ है। हाउ मच टाइम विल इट टेक फॉर अ 20 ग्राम, दिस इज योर इनिशियल कंसंट्रेशन, ठीक है, of the reactant to reduce to 5 gram, this is your final concentration. You have to calculate the time.
सर हमें लॉग की वैल्यू कितने डिजिट्स तक लेनी होगी, मतलब
2 डिजिट काफी है। वो डिपेंड करता है आपके पास ना कि ऑप्शंस आप देखिए पहले। देखिए ऑप्शंस में बहुत वेरिएशन है, राइट। तो डेसिमल के बाद 2 डिजिट काफी होगा। टाइम विल बी इक्वल टू 2.303 डिवाइड बाय k, that is equal to 10 to the power -2, 10 to the power -2 log of a naught is 20 upon 5, तो दिस इज log 4। अब log 4 के जिनको वैल्यू नहीं पता है उनसे आंसर नहीं
0.60।
आएगा। 0.60303 into 100 हो जाएगा ये। 10 to the power -2 will go above, it will become 10 to the power 2 into log 4 की वैल्यू होती है 0.60, ठीक है। तो 0.6 into 2 somewhere around कितना आएगा आपके पास, दिस विल बी somewhere around 1.2 into 100, so 120 से थोड़ा ज्यादा कौन सा वैल्यू है, ये विल बी द आंसर। देखिएगा कैलकुलेट करके। When the values are very far apart, please approximate, है ना। आपको जरूरत नहीं है 2.303 से पूरा मल्टीप्लाई करने के लिए। You just multiply 0.6 into 2, it will give you 1.2. 1.2 into 100 will give you 120. And as you have seen, आपने कम लिया है, 2.303 नहीं लिया, आपने क्या किया, 2 into 0.6 किया। So obviously the answer should be what? The real answer should be a bit more than 120. ठीक है? So a bit more than 120 is 138.6. So that answer should be correct. There is no rule for approximation. हम आपको कोई एक चीज नहीं बता सकते कि यहाँ पे approximate हो सकता है और यहाँ पे approximate नहीं हो सकता। It will depend on the options and the calculations also. So what I suggest is that whenever you do some calculation, try to approximate first and then look at the option and then try to pick up the option. अगर approximation से आपको answer आ जा रहा है then it is fine. Always try this in each and every question जहाँ पे भी आपको calculations आ रहे हैं. Try to approximate in all the questions. तभी you will have an intuitive idea कि कहाँ पे approximate कर सकते हैं और कहाँ पे नहीं कर सकते हैं. Chलिए, moving on. Write this one. The rate constant for a first order reaction is this much. This is again K. Time required to reduce 2 gram of the reactant to 0.2 gram. Okay, this is even easier. Yes, Arpit, very good, correct. What happened? बाकी लोग का आंसर क्यों नहीं आ रहा है? Yes, Anna, Iram, Heather, what happened? Anna, tell me.
I'm doing, sir.
जी कैसे करें बताइए. इतना टाइम नहीं लगना चाहिए. Doing कैसे करें बताइए. What is the formula that you are using? What is the equation that you are using?
2.303 by K.
T is
log
equal to 2.303 divided by K.
by
What is K?
K.
4.6.
K is 4.606.
ठीक है. Into 10 to the power 3.
Yes.
It was in the denominator with -3. सही है.
Yes.
Okay. Into log of what is
Log
A0
of initial, that is 2 gram,
divided by.
0.2.
So I can cancel this by 2. 10s are. Yes or no? 0.2 into
Yes,
10. है ना? So log 10 is equal to how much?
1.
है ना? Yes, Heather, correct. B answer. Iram, what happened with you? Yes, Iram.
Yes, sir.
आप बताइए क्या हुआ? Yes, sir, क्या? Why did you not give the answer?
I've sent the answer.
You have sent the answer. किसको भेजा? अच्छा, B भेज दिया आपने. ठीक ठीक, my bad. Okay. What about this one? Correct difference between the first and the second order rate reaction is that. अभी देख लीजिए इसको, है ना? Because we have to do some others also. Time नहीं ज़्यादा बचा हुआ है. The rate of correct difference between first and second order. The rate of first order reaction does not depend on the reactant concentration. गलत statement. Half-life of the first order reaction does not depend on A0. Correct statement. Half-life of the second order reaction does depend on A0. That is also correct statement. First order reaction can be catalyzed, or second order reaction cannot be catalyzed. False statement. All of the reactions can be catalyzed. The rate of the first order reaction does not depend on the reactant concentration. Rate of first order, galat statement. So the only correct statement is B. Yes, I'm correct. That is B. Okay, so moving on to collision theory and temperature. Collision theory says that all the reaction happens because only and only if there are two conditions that are satisfied. The reactant molecules should have some minimum threshold energy and they should collide with each other with proper orientation. They should collide with each other with proper orientation. These are the two conditions for a reaction, for effective collision, and each effective collision brings about the reaction. Now, threshold energy is equal to the potential energy of the reactant, that is the energy that is already present, and the activation energy. Okay, and the activation energy. So what is activation energy? Activation energy is the additional energy that is required in order to reach the threshold energy, Now, we have two different types of reaction. We have endothermic reactions and exothermic reactions. Okay. Now, in endothermic reaction, the enthalpy of reaction is positive. That means the initial state of the reactant is here, and the final state of the product is here. So obviously, you can see that the energy has increased. And when the energy has increased, how can the energy increase? Energy can only be increased if you give energy. And if you're giving the system energy, that is an endothermic process. In exothermic process, you can see that the energy is going below. And when the energy is going below, in that case, I can say what? In that case, I can say that energy has been released. Energy kahan jayega? Kam hoke kahan chala jayega? Energy will be released, and that is why it is known as exothermic. So delta H is positive for endothermic, and exothermically delta H is negative. Okay. Now also one more thing, delta H will be equal to activation energy of forward minus activation energy of backward. Okay. Or we can also write enthalpy of the product minus enthalpy of reactant. इसको ये लिख लीजिएगा, शायद वहां पे दिख नहीं रहा आपको. Delta H is equal to activation energy of the forward reaction minus the activation energy of backward reaction. Okay. So please write this down. Next, another thing that is very important is the factors that affect the activation energy. There are only two things that can affect the activation energy. One is nature of reactant and the catalyst. इसके अलावा कोई भी चीज activation energy को affect नहीं करेगा. Okay, it is not going to affect the activation energy. With respect to catalyst, there are two types: positive and negative catalyst. This must be new for you. Positive catalyst reduces the threshold energy, it reduces the activation energy, and it increases the rate of reaction. Positive catalyst डालने से क्या होता है? Rate of reaction बढ़ जाता है. Negative catalyst डालने से rate of reaction घट जाता है. As simple as that. Okay. Next, we have the temperature dependence of the rate constant. Rate constant temperature पे कैसे depend करता है? It is given by Arrhenius equation. And Arrhenius equation says that K is equal to A into e to the power minus EA upon RT minus EA upon RT. When you put log in both the sides, you will get log K is equal to log A minus EA upon 2.303 RT. Okay, so this is the equation that you have to memorize. Now, for two different temperature, what is the equation? When you have two different temperatures given, in that case, log of K2 upon K1 will be equal to EA upon 2.303 R divided by, multiplied by 1 upon T1 minus 1 upon T2. When you have two different temperatures given and the rate आपको वहाँ पे बताया रहा है कि generally वो बोलते हैं कि rate double हो जाता है इस temperature से इस temperature जाने में. So when they are talking about rate, they are indirectly talking about the rate constant itself. Okay. So and they will ask you to calculate the EA. One important thing is 2.303 into R, it is approximately equal to 19.1. तो इसको भी लिख लीजिएगा. So you don't have to multiply 2.303 into R all the cases. Please write these things down.
So what is the activated complex?
Activated complex is, for example, if you have, let us suppose H2 plus I2. H2 होता है इस तरह से and I2 is like this. So when they are going to react, what is going to happen? H will interact with I and this H will also interact with I. So there will be a point where there is a partial bond between these two H and there's a partial bond between these two I. Okay, these bonds are breaking and the bonds between hydrogen and iodine, these are forming. ठीक है, so इस complex को बोलते हैं activated complex. जो transition state होता है ना, आप लोगों ने पढ़ा होगा organic chemistry में, transition state, that is the activated complex. Okay.
Okay, sir.
Now, activated complex differs, अलग हो जाता है when you add a catalyst. ठीक है, so activated complex can be different for a reaction if you add a catalyst वहाँ पे. Will you please try this question? The addition of catalyst during a chemical reaction alters which of the following quantities?
So in the above picture, in front of positive catalyst and negative catalyst, the second where there is a decreasing arrow after TE, what is that? Is it activation energy or
That is
enthalpy?
activation energy. Yeah, that is activation energy.
Okay, sir. And this
Activation
will
energy.
be
This would be B, huh? And also, as you can see here, ना, the factors affecting activation energy में क्या है? Nature of reactant and catalyst. ठीक है, तो catalyst किस किस को काम करेगा? Catalyst changes the activation energy only. Okay. ये सवाल कीजिए. For reaction A to B, the enthalpy of a reaction is minus 4.2 kilojoule per mole. Enthalpy of activation is 9.6. ठीक है. Enthalpy का सॉरी एक्टिवेशन देखते हैं आपके लिए. This thing is activation. ठीक है, वो तो आपको पता नहीं चलेगा because it is not graphed actually with numbers. But enthalpy is minus 4.2. Enthalpy minus इसका मतलब क्या? एंडो है या एक्सो है बताइए.
एंडो सर.
endothermic.
अरे एक्सोथर्मिक है भाई, नेगेटिव है ना, कम हो गया है. That means it is releasing. Yes or no?
Yes, sir.
ठीक है. यहाँ पे क्या हो रहा है बताइए? एनर्जी इंक्रीज हो रही है. ठीक है, यहाँ पे एनर्जी सेम है. The only case is यहाँ पे एनर्जी डिक्रीज हो रही है, यहाँ पे एनर्जी इंक्रीज हो रही है. So which of the case will tell you about the exothermic? This is the option A, B, C, and D. So C is the correct option. No? C option is giving you exothermic reaction. Clear है? Yes or no, please tell me, guys.
Yes, sir.
Okay.
Yes.
Try this. Slope of Arrhenius plot ln K versus 1 upon T for the reaction -5. Okay, the value of EA for the reaction is, choose the correct option. यहाँ पे उन्होंने स्लोप दिया हुआ है -5 into 10 to the power 3. What is the slope for ln K versus T? What is the equation that we have? Ln K is equal to ln A minus EA upon G. देखिए इस इक्वेशन में यू हैव लॉग टर्म्स. ठीक है, लॉग को ln में कन्वर्ट करना है तो सबको ln कर दीजिए और 2.303 हटा दीजिए. तो माइनस EA अपॉन क्या आ जाएगा आपके पास? यू विल गेट RT. ठीक है, R and 1 upon T हम यहाँ पे लिख रहे हैं. तो दिस इज माई Y, दिस इज माई C, माइनस EA upon R is my slope and 1 upon T is my X. ठीक, स्लोप उन्होंने क्या बोला है? स्लोप इज इक्वल टू -5 into 10 to the power 3. सो स्लोप है आपके पास माइनस EA upon R is equal to -5 into 10 to the power 3. माइनस माइनस कैंसिल हो जाएगा. ये विल बी इक्वल टू -5 into 8.314. सॉरी -5 नहीं, 5 हो जाएगा. 8.314 into 1000. सो 8 5s are 40. बी होगा आंसर. देखिए calculate this value, you will get B answer. 5 into 8.314, 41.5 into 1000 मल्टीप्लाई कर दिएगा, so you will get 41.5 किलोजूल. है ना? इस 1000 आप किस में लिख सकते हैं? K में लिख सकते हैं, किलोजूल पर मोल. So 8 5 are 40, so B is the answer.
Can you explain the equation part once again?
अच्छा, what is Arrhenius equation? K is equal to A into e to the power minus EA upon RT. Put ln natural log on both the sides, you will get ln K is equal to ln A into e to the power minus EA upon RT. ठीक है? Now using the formula of log, that log A into B, log A into B is equal to log A plus log B. So ln K will become ln A plus ln of e to the power minus EA upon RT. Now this power will come down and it will become what? Power नीचे आके क्या बन जाएगा आपके पास? Let me just move this here. Minus EA upon RT will come down. ठीक है? Minus EA upon RT यहाँ पे आ गया. Now natural log of E. So log with base E and it is also of E. So this will become equal to 1. So ln E is equal to 1 and your equation will become plus into minus minus ln A minus E upon RT. ठीक है? Now ln K is what is my Y. ln K दिया हुआ है आपको. ठीक है? ln A क्या हो जाएगा आपके पास? It is a constant, so it will be C, the intercept. Minus EA upon R will be equal to your slope, that is M, and 1 upon T क्या दिया हुआ है उन्होंने? X दिया हुआ है. Y versus X होता है ना? What is X? 1 upon T. So your slope will be minus EA upon R. Now, the same question was given and आपको बोला रहा था कि it is log K versus 1 upon T. Then in that case आप क्या use करते? The slope would be equal to minus EA upon 2.303 R use करते हैं. Okay, if it was log. And since it is ln, it is, you're not putting this 2.303 term. All right, this next question. Increase in the concentration of reactant. Understood, Heather? Yes or no? Tell me.
Yes, sir.
Okay. An increase in the concentration of reactants of a reaction leads to change in. Take 1 minute for this question, not more. Concentration increase करने से क्या होगा? When the concentration of the reactant of a reaction is changed, okay, an increase is there. Change नहीं, increase है. So when you are going to increase the concentration, then in the same volume you have more number of molecules, and if there are more number of molecules, their chances of colliding with each other also increases. Okay, that is why what is going to change? The collision frequency is going to change. Threshold energy किसी भी के लिए change नहीं होता until unless you add a catalyst. Activation energy भी किसी के लिए change नहीं होता until unless you add a catalyst. Heat of reaction never changes until unless you change the reactant itself. जब तक आप reactants को change नहीं करेंगे तब तक heat of reaction change नहीं करेगा. ठीक है? So the correct option will be concentration की increase करने से collision frequency increase हो जाएगी. Now this is again from the previous questions. उसी तरह से activation energy of a reaction can be determined from the slope of which of the following graph? ln K versus T, है ना? ln K versus 1 upon T. ना इस तरह के सवाल आ जाए तो बहुत अच्छा, आपके लिए बहुत आसान सवाल होते हैं. For a reaction between A and B, the order with respect to A is 2 and the order with respect to B is 3. The concentration of A and B both are doubled. The rate will increase by a factor of what? See, जब भी आपको इस तरह के चीज है ना कि ए और बी दिया हुआ है और कोई डबल कर रहे हैं, कोई ट्रिपल कर रहे हैं, कोई हाफ कर रहे हैं. सो व्हाट यू हैव टू सी, द चेंज इन द रेट विल बी, change in rate will be equal to, हाँ ठीक है हम देखते हैं, whatever change you are having for a concentration to the power of its order. ठीक है, तो यहाँ पे क्या क्या चेंज हो रहा है? चेंज हो रहा है सबसे पहले क्या, ए को क्या कर रहे हैं, डबल कर, और उसका ऑर्डर कितना है, ए का ऑर्डर है 2. और क्या कर रहे हैं, बी को भी डबल कर रहे हैं, तो चेंज हो रहा है डबल टू दी पावर 3. सो 2 2 4 और 2 to the power of 3 will be equal to 8. So 8 4 का कितना हो जाएगा, 32. So the answer will be 32. ठीक है, तो इसको याद रख लीजिए. डेल्टा मीन्स चेंज. ओके, सो हाउ विल द रेट चेंज, इंक्रीज या डिक्रीज कुछ भी होने वाला है, दैट विल बी इक्वल टू चेंज टू द पावर ऑफ ऑर्डर. ठीक है, चेंज 1 to the power of order 1 into चेंज 2 to the power of order 2. ठीक है, इस तरह से ए और बी जब दोनों चेंज हो रहा है तो मल्टीप्लाई करेंगे, दोनों को सी रहता तो सी को भी मल्टीप्लाई करते. प्लीज राइट दिस डाउन. You see this question? This is from the first order reaction. ठीक है, reaction is 50% complete in 2 hours, 75% complete in 4 hours. As I have told you guys, for first order reaction 50% complete होता है जितने टाइम में, उसका डबल टाइम लगता है 75% complete होने में. अगर ये 50 लग रहा है, ये भी 50 सेकंड लगेगा, एंड टोटल कितना हो जाएगा 100. सो 50% कंप्लीट करने में लग रहा है 50 seconds एंड 75% कंप्लीट करने में लग रहा है 100, है ना. सो हियर आल्सो वी हैव 2 hours एंड 75 के लिए 4 hours. सो द ऑर्डर विल बी फर्स्ट ऑर्डर रिएक्शन. See, this question will be done in this way. Log of K2 upon K1 is equal to EA upon 2.303 R multiplied by 1 upon T1 upon 1 upon T2. ठीक है, so first of all convert T1 and T2 to Kelvin. इन दोनों को Kelvin scale में convert कीजिए. Plug the values here. EA upon 19.1 कर लीजिए. K2, they are saying the rate doubles. K2 आप ले लीजिए 2K and K को ले लीजिए आप K. T1 को लीजिएगा आप 20 डिग्री सेल्सियस एंड T2 को लीजिएगा आप 35 डिग्री सेल्सियस आफ्टर कन्वर्टिंग टू व्हाट, आफ्टर कन्वर्टिंग टू द केल्विन स्केल, एंड देन यू कैन फाइंड आउट द वैल्यू ऑफ EA. आप सिर्फ कैलकुलेशन बचाए यहाँ पे, नथिंग एल्स. ओके, सो if I write some more simplification, so this will be log 2 will be equal to EA upon 19.1 1 upon T1 minus 1 upon T2. ठीक है, so T1 T2 में प्लग इन कीजिएगा केल्विन स्केल की वैल्यूज and then you will calculate for EA. Chemical kinetics में you will not get कुछ ज्यादा difficult questions नहीं आते हैं. जो आपने बोर्ड्स सारे जितने भी सवाल है ना, except for that mechanism 1, mechanism के अलावा जितने भी सवाल है सारे के सारे बोर्ड सिलेबस से हैं. Okay, so, and this type of questions are also present in your NCERT textbook. So please take a screenshot. And that's it for today. ठीक है, we'll meet next, कब मिलेंगे हम लोग, Thursday ना, we'll meet on next Wednesday. We'll have a test on Friday, that is tomorrow. ठीक है, Friday का आपका टेस्ट होगा. Please attend that test. Attempt कीजिएगा सवालों को. I think that is your first test on Friday. पहला mock test होने वाला है. चलिए, done everyone. Yes, no, please tell me. Syllabus will be 2 chapters, solutions and chemical kinetics.
And so mole concept.